I really feel like talking about today? Spaghetti. I love spaghetti. It's so good, and I haven't had it in forever. But actually, what we need to do is talk about domain and range of functions. A function is a relationship that pairs each input, what we also generally refer to as x values, with one output, what we generally refer to as the y values. The domain, and this is going to be a word that's going to keep popping up, is the set of all possible x values, or set of all possible input values. The range, again, another word that's going to keep popping up, and it has a different meaning than you probably think. Like generally we think of range of motion or something like that, but this is the range in a mathematical sense, the set of all possible y values. So a function is a relationship that pairs x's and y's together, just like coordinate points. And the domain is the set of all x values that consist in that function. And the range is the set of all possible y values that exist in that function. So, the beautiful little function machine here, we have input values that go into the function, and they get outputted at the other end. We will return back to that depiction in a minute. Example 1, find the domain and range of a function. So, this right here, these 4 points, are representing to me a function. They're representing certain points, certain xy points, and they can give me, some good information, what the domain and range are of the function. So let's take a look. What point do I have right here? I have -3, -2. I can write that down here. -3, -2. What other points do I have? I have -1, 0. What other points? I have 1, 2. Very good. And then I have 3, 4. Good. Now all of these are x, y coordinate points. So all of them consist of an x, or an input, and a y, or an output. So what I'm going to do is I'm going to do a little bit of highlighting. Highlight! Red is going to be my input. Input x, input x, input x, right? Those are all of the x values. And blue will be my output. -2, 0, 2, 4. So what I said before up in the top was that the domain is the set of all possible x values. So the domain of my function should be the set of all of these x's. So in red, my domain, in nice little curlicue brackets, consists of -3, -1, 1, and 3. And by putting them in brackets there, I'm using what's called set notation. And this is my domain. Beautiful. Now let's take a look at the range. The range is the set of all possible y values. So my range, in nice little curlicue brackets, is -2, 0, 2, 4. And that is my range. It doesn't need to be any more complicated than that, folks. When an equation represents a function, the variable that represents the input values is the How many of you are raising the volume right now, trying to see if I cut out? It's hilarious. Okay, so when an equation represents the function, the variable that represents the input values is considered to be what's called independent. Because it can be any value. It's independent of any sort of action from the function. So my x values in here, they're all considered to be independent, and we'll talk about that with the function machine. The variable that represents outputs is generally called dependent, because it depends literally on the value of the independent. So let's look at the function machine. My input is literally any number that I was looking for, any number I wanted. So that was independent of any outside um, projection. The function itself takes that input and it's going to mess with it, it's going to do some stuff, and it's going to output a y. That y is completely dependent on the number that I put into the function in the first place. So the first number that I put in, the x, is independent. The number I get out, y, is dependent. Now let's take a look at some of that in an example. The function y equals negative 3x plus 12 gives the amount y in fluid ounces of juice remaining in a bottle after you take some x size gulps. Identify the independent and dependent variables. Okay, well, we just talked about the fact that the x, or the input, the number that we're going to be inputting, so in this case that's how many gulps you take, right? Because this is, y is telling me how much I have left, how much fluid I have left. X is telling me how many gulps I take. So that amount of gulps could change, and it's completely independent. It tells me, I mean, I could say I take 1 gulp, I could say I take 12 gulps, but nothing's telling me specifically how many I have to take. So independent is the x, which represents gulps. Now that leaves the dependent to be the y, which represents the amount of fluid. Very cool. The domain is 0, 1, 2, 3, and 4. What is the range? Okay, so domain is set of x values. So this is telling me that I put in x values of 0, 1, 2, 3, and 4. I take 0 gulps. I take 1, 2, 3, or 4 different gulps. What is the range? What's the amount of fluid that's left over when I take 0 gulps, 1 gulp, 2 gulps, 3 gulps, and 4 gulps? Well, let's take a look. I'm going to put this in an XY chart. Inputs 0, 1, 2, 3, and 4. So I'm putting my entire domain underneath the x values. And I will put output values of y right next to them that correspond. So when I put a 0 into the function, I go negative, do it over here, negative 3 times 0 plus 12. And what do I get? I get 12. 12 ounces remain. When I put a 1, negative 3 times 1 plus 12. Negative 3 times 1 is negative 3. Negative 3 plus 12, 9. 9 ounces left. When there's a 2, negative 3 times 2 plus 12. Negative 3 times 2 is negative 6. Negative 6 plus 12, 6. When there is 3 big gulps, that is going to be a negative 9. Negative 9 plus 12. We're kind of going in the exact opposite way. Now we're going to start to see a little bit of reciprocity. We have negative 9 and 12. That's going to be 3. And then 4. Negative 3 and 4 big gulps. That gets me negative 12 plus 12. There is nothing left. So 4 big sips and that juice is gone. So now my last question is, what is the range? Well, I said before that I was inputting the domain in for the x's, so all of my domain was down here, 1, 2, 3, and 4. Then my range is all the y's. So my range is the set of all y values, curlicues, which consists of 0, 3, 6, 9, 12. Beautiful. Last example. The table shows the percent y in decimal form of the moon that was visible at midnight X days after January 24th. Okay, so that seems, somewhat easy enough. I can wrap my head around what these things mean. So the table shows the percent y in decimal form of the moon was visible. So this must mean that it was 76% visible. This must mean it was 65% visible, 54%, 43%, 32% visible. Okay, so when was this visible? So at midnight, X days after January 24th. So if this is 0 days after January 24th, this must be actually January 24th, right? If this was one day after, then this must be January 25th. This must be the 26th. 3 days after must be the 27th. And 4 days after must be the 28th. Interpret what the date... Oh, look at that. I just did part A. Interpret what dates the domain represents. The domain is my x values, and we just described what all of those x values meant in terms of the date. January 24th through the 28th. What percent of the moon was visible on January 26th? Okay, so that means I need to look at which part of my range, which y value, corresponds to this x value that represents January 26th, 2 days after the 24th. It was 0.54% visible. Beautiful. You couldn't see it, but I just did a big thumbs up. All right, work on the problems that were assigned. Make sure you ask any questions that you need to on your paper. We can go over those in class. I will see you guys later. Good luck.